The year is 1145. Northern France. Workers are laying stones for what will become Chartres Cathedral. They mix lime mortar by hand, cure timber for years before cutting it, and carve blocks with tools that would seem primitive by any modern standard. None of these workers will live to see the building completed. Their children might not either. The structure will take over a century to finish. And yet, nearly 900 years later, that cathedral still stands. It has survived fires, wars, revolutions, and centuries of weather that would reduce most modern structures to rubble. Millions of people still walk through its doors every year. Now consider the apartment complex built in 1985, just 40 years ago. The concrete is already cracking. Water infiltrates the walls. The facade requires constant repair. Engineers debate whether renovation is even worth the cost, or whether demolition makes more financial sense. 40 years versus 900. Something is deeply wrong with this picture. Welcome to the Medieval Advantage. I'm glad you're here. On this channel, we examine forgotten knowledge, not to romanticize the past, but to understand what modern life has quietly abandoned. Today, we're exploring one of the most visible yet overlooked failures of modern civilization. Why do our buildings fall apart so quickly while medieval structures endure? The assumption most people carry feels obvious. Modern technology is superior. We have advanced engineering, computer modeling, industrial materials, and construction techniques refined over centuries of progress. If medieval buildings survived, it must be because we only remember the exceptional ones. The failures crumbled long ago, leaving a biased sample of survivors. This assumption contains a grain of truth. Not every medieval building lasted. Many structures, particularly humble wooden dwellings, did decay and disappear. But the assumption misses something fundamental. Medieval builders weren't trying to create monuments. They were trying to create buildings that worked for generations, for centuries, for futures they couldn't predict. And their success rate, even accounting for survivorship bias, far exceeds what modern construction achieves. We build faster, cheaper, and at unprecedented scale. We also build structures that require major renovation within decades and demolition within a human lifetime. It turns out we've been measuring the wrong thing. Modern construction measures success by initial cost, construction speed, and compliance with minimum regulatory standards. A building that meets code and comes in under budget is a successful building, regardless of how it performs in 50 years. Medieval construction measured success differently. A building succeeded if it still functioned when the builder's grandchildren had grandchildren. A bridge succeeded if it carried traffic for centuries. A cathedral succeeded if it still inspired awe 500 years after the last stone was placed. The question isn't whether medieval buildings were better. The question is what they were optimized for and what we optimize for instead. Let's begin with materials. Modern construction relies heavily on Portland cement, concrete, and steel. These materials are strong, versatile, and can be produced at industrial scale. They enabled the modern world, skyscrapers, highways, massive infrastructure projects that would be impossible with traditional materials. But they have a hidden flaw. Concrete and steel are rigid. They don't flex. When stress occurs, thermal expansion, settling, seismic movement, they crack. And once cracked, water enters. Water corrodes the steel reinforcement inside concrete. The corrosion expands, creating more cracks. The cycle accelerates. Modern concrete structures begin deteriorating almost immediately. The process is often invisible for decades, then suddenly catastrophic. Medieval builders used different materials with different properties. Stone and lime mortar formed the backbone of major medieval construction. Lime mortar behaves fundamentally differently from Portland cement. Lime mortar is softer than the stone it joins. When movement occurs, the mortar absorbs the stress rather than transferring it to the stone. Small cracks can actually self-heal. Lime mortite continues to white over time, sealing minor damage without intervention. The building breathes, it moves, it adapts. When repairs become necessary, lime mortar can be removed and replaced without damaging the surrounding stone. The system is designed for maintenance, not replacement. Modern concrete doesn't breathe, it doesn't heal, it doesn't adapt. It resists stress until it fails, then fails catastrophically. This isn't a flaw in concrete technology. It's a flaw in how we think about buildings. We design for initial strength. Medieval builders designed for long-term resilience. Repairability reveals an even deeper difference in philosophy. Walk through a medieval building and you'll notice something subtle. The structure is visible. You can see how stones fit together. You can identify individual timber beams. You can understand, with basic observation, how the building works. This visibility was intentional. Medieval builders expected buildings to be repaired. Not might need repair someday, would definitely require ongoing maintenance for as long as the building stood. Every component was designed to be accessed, assessed, and replaced when necessary. A damaged stone could be removed and a new one fitted. A rotted timber could be sisted or replaced. The knowledge required for repairs was widely distributed. Local craftsmen understood local buildings. Modern construction hides everything. Walls conceal wiring, plumbing, insulation, and structural elements behind layers of drywall and cladding. Identifying problems requires destructive investigation. Repairs often require specialized contractors with proprietary knowledge. When a modern building develops issues, the complexity of diagnosis often exceeds the cost of simply demolishing and rebuilding. We've created buildings that cannot be economically maintained. This is not an accident. It's a design choice, optimizing for speed and initial cost at the expense of long-term functionality. Medieval builders optimized for the opposite. Perhaps the most striking difference lies in how medieval buildings handled the future. Modern buildings are designed around assumptions about climate control systems that will regulate temperature, assumptions about energy supplies that will power those systems, assumptions about how the building will be used, who will occupy it, what technologies will be available. When assumptions fail, modern buildings fail with them. Consider a standard office building constructed in the 1990s. Its walls are thin. Insulation handles temperature regulation. Its windows are sealed, mechanical ventilation provides air. Its floor plans assume specific uses, open offices, cubicle farms, computer workstations. 30 years later, those assumptions have shifted. The HVAC systems require constant, expensive maintenance. Energy costs have risen dramatically. The floor plans don't accommodate current work patterns. The building's entire logic no longer matches reality. Medieval builders made almost no assumptions about the future. They couldn't. They had no climate control systems to rely on. They had no confidence about future uses. They built for uncertainty as the default condition. The result was thick walls with massive thermal mass. Stone and masonry absorbed heat during warm periods and released it during cold ones. The building itself regulated temperature passively, without mechanical intervention. Windows were sized and positioned to maximize natural light while minimizing heat loss. Orientation was chosen based on sun patterns that would remain constant for millennia. These buildings didn't require specific technologies to function. They didn't depend on energy inputs that might become unavailable. They worked with physics rather than fighting against it. A medieval building could lose every system we consider essential: electricity, heating, cooling, plumbing, and remain habitable. A modern building loses power for a week and becomes uninhabitable, sometimes permanently damaged by frozen pipes or failed ventilation. We call this progress. Time horizons reveal the starkest contrast of all. When medieval craftsmen began work on a major cathedral, they knew they would never see its completion. Construction would span generations. The master mason who laid the foundation might be dead 50 years before the spire was finished. This knowledge shaped everything. There was no incentive to cut corners for short-term savings, no pressure to meet quarterly targets, no developers planning to sell the project and exit before problems emerged. The builders worked for a future they would never inhabit. Their reputation and the reputation of their craft guilds depended on quality that would be judged by people not yet born. Modern construction operates on precisely opposite incentives. Developers finance projects with loans that must be repaid quickly. Buildings are assets on balance sheets, evaluated by returns over 5 to 10 years. The people who design and finance buildings rarely occupy them long enough to experience their failures. When a roof begins leaking 20 years after construction, the developer has long since sold and moved on. When concrete starts cracking after 30 years, the original builders bear no consequences. The costs of failure are externalized to future owners, future tenants, future generations. We build for exit strategies, not for centuries. This isn't corruption or incompetence, it's rational behavior within a system that rewards short-term optimization. Medieval builders operated within a system that rewarded the opposite, long-term durability verified by time itself. Maintenance culture has almost entirely disappeared from modern thinking. Medieval buildings required constant attention, not because they were poorly built, but because maintenance was understood as normal and necessary. Small repairs prevented large failures. Continuous care extended life indefinitely. This maintenance wasn't performed by specialists flown in from distant cities. It was embedded in local communities. The knowledge of how buildings worked, what they needed, and how to care for them passed through generations of local craftsmen. A village understood its church. A town understood its bridge. The relationship between community and structure was ongoing, intimate, and multi-generational. Modern buildings are maintained, when they're maintained at all, through deferred maintenance budgets that are perpetually underfunded. We wait until systems fail catastrophically, then spend enormous sums on emergency repairs. This approach seems economical in any given year. Maintenance budgets are easy to cut when other priorities press. The consequences appear only later, when accumulated neglect produces failures that dwarf what preventive care would have cost. We have lost the understanding that buildings require relationships, not just repairs. How did we arrive here? The shift happened gradually, driven by forces that seemed beneficial in isolation. Industrialization enabled mass production of building materials. Standardization reduced costs. New materials like Portland cement and structural steel made previously impossible structures achievable. Cities grew rapidly, demanding construction at scales traditional methods couldn't match. None of this was wrong. Industrial construction fed and housed billions of people. It created the modern world. But alongside these changes, something else shifted. Buildings became financial instruments. Housing transformed from shelter into investment. Commercial real estate became an asset class. Construction became a vehicle for capital deployment, rather than a craft aimed at creating lasting structures. When buildings are assets, their value lies in financial returns, rental income, appreciation, tax advantages. Physical durability matters only insofar as it affects these returns. A building that lasts 200 years offers no additional financial benefit over one that lasts 40, if the investment horizon is 20. The goal quietly changed, from sheltering people to optimizing spreadsheets. Let me be absolutely clear about something. This is not an argument against modern technology. Modern engineering has achieved genuine marvels. We can build structures medieval people couldn't have imagined. Earthquake-resistant skyscrapers, bridges spanning miles, buildings that function in extreme environments. This is not romantic nostalgia for medieval hardship. Medieval life was difficult in ways we can barely comprehend. Medieval buildings served people with shorter lifespans, fewer comforts, and far fewer choices. This is about alignment. Medieval builders aligned their methods with their goals, creating structures that would serve communities for centuries. Modern builders often align their methods with different goals, maximizing returns within investment timelines, minimizing initial costs, meeting regulatory minimums. The buildings that result reflect those different alignments. Let's return to Chartres. Nearly 900 years after those first stones were laid, the cathedral still stands. Its lime mortar has continued curing across centuries. Its stone has weathered but not failed. Its structure has absorbed wars, fires, and countless winters. It required no electricity to build. It requires no electricity to stand. It was designed for a future its builders couldn't predict, and it has met that future again and again. The workers who began it knew they were building for eternity, not as poetry, but as practical intention. They knew because their culture, their incentives, and their understanding of what buildings meant all pointed toward the same horizon, as far as human imagination could reach. What are we building today that will still stand in 900 years? What are we building that will still stand in 90? Modern civilization constructs at unprecedented scale. We build more square footage in a decade than medieval Europe, built in centuries. We house billions. We connect continents, but we build to fail. Not because we lack the knowledge to build durably. The engineering exists, the materials exist, the techniques exist. We build to fail because our systems reward failure. Because durability offers no financial advantage within investment horizons. Because the costs of collapse fall on people who haven't been born yet. We didn't forget how to build. We decided not to. What else have we decided without quite admitting it to let fall? Apart, what other systems are we optimizing for short-term returns while externalizing long-term collapse? These questions extend far beyond architecture. They reach into infrastructure, institutions, economies, and the relationship between present and future that defines civilization itself. On this channel, we examine what modern life has abandoned, not to return to the past, but to understand what still matters and what we might yet reclaim. Thank you for watching this video. I genuinely appreciate you taking the time to think through these questions with me. If you value this kind of long-form exploration, calm, serious, and willing to ask uncomfortable questions, please take a moment to like this video and subscribe to the Medieval Advantage channel. Your support makes this work possible. In the next video, we'll explore another forgotten system, how medieval communities managed shared resources without modern regulations, and what their solutions reveal about problems we still haven't solved. I'll see you in the next one.